Good morning. This is your Stat Sensei, and we're going to talk a little bit about hypothesis test. And in this video, we're just going to hit the concepts of hypothesis testing. We're not going to run any of them. We will do that in some separate videos. So first off, you learned about hypotheses in your science classes, where you said it was an educated guess or it's an assumption about the population. We like to say it's an assumption about a population parameter. And remember, a parameter is just a measurement of the population, whether it's the mean of the population or the standard deviation. Now, because it's an assumption, it may or may not be true. All right. Well, hypothesis testing or running a hypothesis test is just the formal procedure used to accept or reject a statistical hypothesis. All right. And we really don't like the word accept, so we don't want to use that word. We either reject it or instead of accepting it, we fail to reject it, right? So we don't ever accept anything because honestly, as statisticians, we're never certain of anything. We're kind of haters. We either reject it or we fail to reject it. In other words, we say that we have enough evidence to say that it's not true. We never have it. We never go to try to prove it. All right. So when we're running our data or we're collecting our data, some of the data is going to lend support to the hypothesis, but it'll never prove it. And in other words, we will never prove the hypothesis. The only thing we can do with it is we can reject the claim. All right. And that's if we have enough evidence against it. So consider this. Consider the logic of a jury trial. In the United States, we always assume the defendant is innocent. That's the null hypothesis. All right. The alternative hypothesis is they are guilty. So what the prosecution does is they sit there and they go, hey, we're going to collect some data and we're going to make a presentation and we're going to try to prove that they are guilty. At the end of the trial, there may or may not be enough evidence to say that they're guilty. And we never say at the end of the trial, well, we'll do one of two things. We'll say, hey, there's enough evidence to say that they're guilty. Or we will say, you know what, we don't have enough evidence. We say they're not guilty. We don't never say that they are innocent. In other words, when O.J. Simpson and Casey Anthony were on trial, the jury didn't come back and say they are innocent of murder. What they said was there's not guilty. There wasn't enough evidence for us to say that they were guilty, so we have to retain the hypothesis. We retain the hypothesis because we failed to reject it. Okay? As I said, we gather evidence against the claim. So if the claim is for a murder victim, if we have a claim for a murder defendant, it's like, okay, the null hypothesis is he's innocent, but we're going to try to prove that he committed the murder or that person committed the murder. It's like, well, we know the murderer is male. Well, that is definitely some evidence that the male person on trial could have done it because he's not a female. But obviously half the population is male, so that's not enough evidence. Well, we know that the person is overweight. Well, once again, over half of the male population is overweight, so you're still working with a fourth of the population. And we add more and more and more evidence, and we never 100% prove it. Never 100% prove it. But at some point, we gather enough evidence. All right. Well, how do we know that we do that? Well, we calculate what is known as a p-value. And a p-value is a probability. Now, it's kind of a complicated probability. First off, it's a conditional probability, which means you should be thinking about, intersection over given, like we had in the probability unit, because it's basically the probability of getting a test statistic this extreme or more extreme, given that the claim is true. In other words, what's the probability we'd have so much evidence that this person committed murder given that they were really innocent. So if we get a really, really small p-value, the smaller the p-value, the more likely we are to reject the claim. I like to use the, reject the null hypothesis, which is the original claim of innocence. I like to use a basketball example. And my example is this. You have a friend that claims that they score 40 points per game. And you're like, wow, that's good. So you ask them about the next game. Oh, I usually score about 40 points. So you show up at the game and they score 37 points. Well, that's not 40, but that's pretty close. So most people go, you know what? I guess he's telling the truth. He scores about 40 points a game. Well, you go to, it wasn't that game. What if he only scored 32? Well, he had an off night. The officials made some bad calls. He was getting fouled. So maybe you believe that. What if he only scored 20? Well, you go and talk to him. He goes, hey, I got injured during the game, so that's what happened. And maybe you accept it. Maybe you don't reject his claim of 40 points. Maybe you believe it. Kind of depends on the person. What if he'd only scored 4 points and he played the whole game or most of the game? Well, at that point, you're like, if you only scored 4 points, there's no way on average you scored 40. And at which point you reject the claim because there's so much evidence indicating that the claim is indeed not true. All right. So once we have enough evidence, we reject the null hypothesis. But sometimes we don't have enough evidence. If your friend scores 37 points, you go, you know what? I can't reject the null. He probably scores about 40 points a game. Just had an off night. Okay. All right. So this is the rest of that note. And this is just a continuation. Once again, on the trial, we'll ultimately say the defendant is, the null hypothesis is that they're innocent. We present data to the contrary, but ultimately we sit there and go, could it plausibly have happened just by chance? In other words, in the basketball situation, by chance, is it possible that he would only score 37 points if he averages 40? And the answer is, yeah, that could probably happen. Is it plausible that he only scored 4 points in a game by chance if he averages 40? And the answer is very unlikely. So you're going to end up with a small p-value. And the smaller the p-value, the more likely you are to reject it. It's like, oh, it's less than a 1% chance of it happening. You know what? I don't think that's likely, so I no longer believe the claim. And you go, well, how small is small in statistics? Well, first off, that measurement is called the level of significance or the alpha level. And we predetermine it. We actually pick it out of the air, and we do so before we actually run any of the data. We go, you know what? I want to be 5%. I only want to be 5% sure. I want 1%. And you pick the number. Now, for AP statistics, we usually pick an alpha. If they don't tell us, we pick an alpha, and it's this Greek letter. It looks like a fish. Alpha equals 0.05. And this is known as your alpha. We also call it the level of significance. And if your p-value is less than your alpha, if the p-value is less, you reject. So p-value less than alpha, we reject. If the p-value is greater than alpha, p-value greater than alpha, we fail to reject. And by the way, we never say it's close, so we don't make a decision. We do not, in statistics, we do not get to be Switzerland. We have to say yes or no. We are either going to reject or fail to reject. All right? So on a hypothesis test, there's basically 4 parts. We have to state our hypothesis, and it's basically the parameter equals. Usually, initially, it's going to be mu equals. That would be your null hypothesis. Mu equals some number. Could have been mu equals 40 points. And the alternative hypothesis, by the way, that we state the null is HO, H naught. The naught means 0 or null. So it'd be mu equals 40 points. That's the claim. And let's just say, hey, I want to know if he actually scored. I believe he doesn't score 40 points. I believe he scores less than 40. Well, the parameters are going to match. The numbers are going to match. The inequality is what's going to change. So it's like, oh, I'm worried that he scores less than 40. You could have said, oh, more than 40, or you could have said, is it just something different, which would be not equal. All right. So less than, more than, and not equal. We always have to give the name or the formula for the test. Personally, I just like to use the formula. And I usually write the formula just by plugging in the numbers. And then we have the conditions. And there are a lot of conditions, and that's kind of a pain. And we'll talk about that in a moment. Then the next thing is we're going to plug values into the equation, and we'll calculate a test statistic and calculate the p-value. And then the final thing is we're going to state whether we reject or fail to reject. And remember, we reject p-value less than alpha, we reject p-value greater than alpha, we fail to reject. And then we state our conclusion in context. Must be in context to receive full points. All right. All right, so that's your basic steps. So I want to do a quick vocabulary review on this. Hypothesis, as we said, is an assumption about the population, specifically the population parameter. And hypothesis testing is a method of determining the validity of the hypothesis. The null is the claim about the parameter. I also say it's the status quo, or what we believe to be true, or what's been assumed to be true, or it's always been the situation. It's what we generally say has been the case. And the alternative is going to be different than the null, but the parameter will be the same. The numerical value will be the same, but you're going to have to worry about the inequality. Keywords for not equal, for using not equal is different. Obviously, this is greater or more, and this will be less and things like that. A two-tailed test is the not equal situation, and it's similar to a confidence interval in that if you end up in either one of these zones, and these are known as the rejection zones, any of those zones, you're going to reject. So it could be either too big or too small. And I really probably shouldn't call it the rejection zone because we've all been rejected at some point. We should probably call it the friend zone. That sounds a little bit better. A one-tailed test, you could have an upper tail. And if you end up in this shaded area, we reject it. We say, you know what, that's too far away. Because remember, we're calculating a p-value. And we go, you know what, this is the claim mean. And if I'm too far away on a two-tailed test in either direction, I reject this mean. If I'm too far above it, I reject the mean. And then a one-tail, lower tail, if I'm too far this way, I reject the mean. So if this value, if this thing gets too small, I reject it. But if it were way over here, it's like, you know what, that's pretty close. But as I get farther and farther this way, I reject. Or if I get farther and farther this way, I'm more likely to reject. Alpha is a predetermined amount of risk or probability of committing a type 1 error. We'll talk about that much later. All right. And we just predetermine it. And it's like, hey, you know, what's the chance that I'm willing to reject the null by mistake? And we say, in AP statistics, we usually choose an alpha of 0.05. And kind of the reason why is this: if you have a if you were taking a multiple choice test with 20 questions, I know you'd like to make 100, but truthfully, if you missed one, you made a 95, you'd probably be okay with it. So it's like, oh, I made one error. That's not that big of a deal. You're generally okay with a 95. The critical value is actually, we don't use these anymore. This is back in the old days. And it's the value, the actual value that would be associated with that probability. The test statistic is either going to be like a z-score or a t-score that we calculate from the sample data. All right, it's what we actually can calculate from the sample data. It's the z-score, t-score associated with that. The p-value is the conditional probability, which tells us how likely we would to get that test statistic given the null was true. And finally, we reject if the p-value is less than alpha. This is always and forever true, amen. It doesn't change. That's why I said it again. Also, we fail to reject if the p-value is greater than alpha. All right, so that kind of concludes our general terms for hypothesis testing. Thank you for watching, and in the next videos, we will actually run some one-sample hypothesis testing. Thank you.